Good day, everybody, and welcome to my physics class. So the topic of today, we are going to focus more on waves. So I'm sure everyone here in this class have witnessed a wave or have seen how waves move in a motion in an ocean, in an ocean. I mean, so when a wave moves, it creates the movements. So that's simply how the waves move. So simply, the wave when it moves, it creates what we call wave trains, right? It creates wave trains. Example of wave trains, I'm going to show you right now. So it's like in a pond, and make a disturbance in a pond, then it creates what the ripples. So ripples is those movement that I would just have created in that pond. Let's take, I have this container here, and I'll pour water in it. I'll pour water. Okay. So yes. So let's take this here is our pond, and in this pond I make a disturbance here. So that disturbance, you could see that it made what we call ripples. So those ripples, we refer them as our waves. Our waves. So that brings us to our topic of today, which is amplitude and pulse. Amplitude and pulse. So anyone here in class can tell me what either an amplitude is or what is a pulse? Yes, at the back.
Says distance from the origin to the turning point of the wave, I think.
Next one. So thank you, sir. So a pulse is simply the effect of a single vibration through what we call a medium. That is simply a pulse. So a pulse is like, let me show you a demonstration of how a pulse moves. Let's take, I have a string. I tie a string here on the wall. Here's our string. Let me tie it. So here's our string. Then I check my string once. See, that's how. Let me check it for the second time. I check my string again. So if we could draw what happened there is we can draw it like this. We tied our string here on the wall, then our string it has moved like this. So this was the movement of our string. So here in our string, here in our drawing, we can come up with this is the time when we come up with the term amplitude, which means it defines as the maximum displacement on a pulse. So an amplitude, let me write it down. It's the maximum displacement on the pulse. This is the definition of amplitude. So we can show our amplitude on our pulse that we have drawn here. So our amplitude, since you can read it of a definition, that is the maximum displacement on a pulse. So which means the pulse is the way the pulse move from its rest upwards to downwards, which is from it move from here to the upwards, then it comes back. So this maximum here that it makes, it is what we call an amplitude. This is our amplitude here. This is our amplitude. We can also um, check another thing on our pulse, which is what we call a pulse length. A pulse length simply means definition of amplitude. So we can show our amplitude on our pulse that we have drawn here. So our amplitude, since you can read it of a definition, that is the maximum displacement on a pulse. So which means the pulse is the way the pulse move from its rest upwards to downwards, which is from it move from here to the upwards, then it comes back. So this maximum here that it makes, it is what we call an amplitude. This is our amplitude here. This is our amplitude. We can also um, check another thing on our pulse, which is what we call a pulse length. A pulse length simply means it's where the pulse move from. It's actually the distance of the pulse. So we can say the distance of the pulse is where the pulse moves to its maximum. And this pulse, let's take it has moved, and now our pulse it has moved from a distance here. So this distance, we don't say is a distance. We say is a distance referred to pulse length. So here is what we call a pulse length, which is what the distance that pulse, the pulse take. This is the pulse length. And another thing, we can also represent our pulse in a graph way, where we can show our magnitude of our amplitude and the magnitude of our pulse length. Let's take, we want to draw our pulse on a graph. We can draw a graph here and label here our graph -1, -2, 1, 2, 3. On the graph, on the graph, on the graph. This is our x of axis. This is our y of axis. And we're given a path to say it moves from rest, it moves from here to here to here. Yeah, our paths move from here to there. So, for example, we're given our our graph here, which demonstrate our path movement. So and I give you the question, what is the amplitude on our graph here? So what you do, since you see what I've told you, that it's a movement of pulse, right? So we can determine our amplitude by the magnitude that we have on the graph. So what we have here, our pulse move from 0, and it moves to here. So our amplitude here, we can say our amplitude is equal to what? Since you know the definition of the amplitude is the maximum displacement on a path. So which is the maximum? You start here from your initial, then you go to your maximum. You start here from your initial, you go. This is your maximum. So this is where you determine the amplitude. So you can clearly see that the amplitude, the maximum here is 1. So simply your magnitude of your amplitude, it is 1. You see, so let's say I give you a question and ask you to find the amplitude. This is how you find your amplitude. And let's take the second question. They ask you what is the path length on our path. So our path length can say, since I told the path length is the distance where the path moves. So you can see the distance of the path that it has moved. It started from zero, which is the initial. It moved from zero, it moved, it moved, it moved, it moved, it moved, until it reaches three. So our distance of the path, our path length is three. Right. And another thing that you must note, which is our NB, our amplitude. Our amplitude, and well, the only thing we can determine our amplitude is on a graph is on the y-axis. So our amplitude we can determine by the values of our y-axis here. On